we'll proceed into the next part, which is the form. So first, if I want to evaluate the straightness for a line, so I can choose first. And then as per normal, so the features is the balloon number, just keys, and then you need to choose your elements. Okay, so for evaluate a straightness of a line, minimum number for the line must be 4 points. So if you are taking a 3 points line, no, minimum number for the line will be 3 points. So if you are taking 2 points line, then it is not able to evaluate the straightness. Okay, so let me take some points. I think line 3 on this side, this one, I have 6 points, so it's able to evaluate the straightness. And then you can see after I select the elements, I can determine the tolerance. So the first one will be the straightness for the whole line, which is the line 3. So right now is the 0.1. And then here I can sorry. So the next one is this one. Is here is the tolerance, also same as here. And then on the behind, I can select the area, which means I can separate it into a shorter length. So now the total length is 553.559. So the deviations will be 36 micron. And if the drawing stated that you need to evaluate the straightness, like maybe 20 mm. So here you put in 20. And then the duration definitely will be lesser because it's a shorter line. Then the you will have a, maybe in this case is 0 deviations, but if I increase to 45, you will have maybe 36. If you want to try again, 40 maybe, and so on. You may have a 20 micron, 10 microns, and so on. So it's depends. And then in last versions, I think we have one more conditions is that if I have a cylinder, I can straight away choose the cylinder here and then evaluate the straightness. Because in the previous versions, if we want to evaluate the straightness of a cylinder, we need to measure one by one, measure the holes in a different circle, and then connect it to a line. And then now we don't need. So let me measure a cylinder first, and I will show you. This. Okay, so I have this cylinder one, and then if I evaluate the straightness, I think I need more points for this case. But you can see that actually I can insert the cylinder. I can choose the cylinder here. Because previously we can only choose the line. And then you will notice that there is a diameter symbol here. It means that the tolerance zone is in a diameter tolerance zone. Is a round tolerance zone. And then you can also put in the maximums and minimum material conditions. Depends on the conditions in the drawing. Okay. So this is how we evaluate the straightness. And for the flatness, if I click in, it will also shows the same interface as the features. element tolerance and deviations. And then for the flatness to be evaluated, we need to have a planes that is more than 4 points instead of 3 points. So let's choose a plane, maybe plane 3, this plane. And then we will have a deviations of 69 microns. And then we can also set the tolerance as well as the second part. This will be the area. So if you have a smaller area, then you definitely have a smaller deviations, like maybe 80. Oh. And in these conditions, it's still the same, but maybe smaller and smaller, then you will have smaller deviations. It's the same as what we have in straightness just now. Okay, so this is my flatness, and then the next one will be the roundness. So as you can see from the symbol, this is for the circle, and then choose a circle which has more than 4 points. Then your tolerance zone, and then this will be in the sector form. So if it is normal one, which is the full roundness, so it will be 360 degree. But if you want to evaluate in half circles, then it will be 100, and so on. Okay. So next one is cylindricity. So definitely is for cylinder, and then we will only have one choice, which is the cylinder for the whole cylinder, which means that we don't have to separate into like few sections or something like that. Yeah, there's no way to do it. Okay, so next ones, and you can see that these forms actually is different from what we have in the first one. The form duration is a different thing. Different as in calculations, and all these calculations is based on the Chebyshev calculation methods, and you will see that actually the results for all these like maybe your flatness of a planes will always lower than the form deviations of the planes. Is always. Okay, and then the next one will be the line profile. So for all this is just care for the form. You just control the form of the elements, like maybe the flatness, whether it is flat or not, but it will not control the locations, orientations, or something like that. But for line profile and surface profile, it can consider the forms as well as control both form, orientations, and locations, and it depends on the datums. So if there is no datum for the line profile and surface profile, then that means that it's just controlling the form. And then if there is a datums, depending on how many datums it have, like ABC, if it is only have an A, then maybe it just care for the locations. And then if it have both, maybe it care for the form, locations, and orientations, and so on. So if I click into the line profile, you can see it's still the same, just a bit more options. So because this is a line profile, so definitely we can only evaluate line profile for curve. So this is my curve one, which is the curve at here, this one. And then this is the tolerance zones as per normal. And then at here, you can see there are different methods of having the tolerance zones. So if the first one is very normal one is that you have an equally disposed tolerance zones. So right now I have total 0.1. So in the evaluations, it will have a 0.05 on top and 0.05 below. So total up will be 0.1, the tolerance zones. So this is the first options. And then the second and the third options, they are actually the same. It's just that one is the ISO standards and the other is the American standard, which is the ASME. And then it means that we will have a tolerance zone on top and below, but they are not equally disposed, which means that on top they might have 0.03, and then below the tolerance zone might be 0.07. So we can key in here. So you can see the deviations will also be adjusted. Same for this one. So the difference is just the difference in the standard. And then the last two is tolerance zone in only one directions, because for the first three we have a tolerance zone in both directions, like maybe 0.05 in the upper and 0.05 in lower. So the last two will be like the tolerance zone in either side, either upper or lower. So depending on which one you choose, either inwards or outwards. Inwards or outwards. So you can see there's a change in the deviations also. But if it is not stated in the drawings, you can simply use this, because this is what most of the manufacturer need to know. And then the next ones, this will be what I mentioned just now, like sometimes the line profile and the surface profile will care for only the form orientations, and some will also care for the form as well as the locations and orientations. And if we choose without reference, which is the best fit, which means that it will try to best fit the actual result with the nominal result, and then try to best fit it and then find the deviations. So this will be the form. You will find for the form. Okay, and then if you have a datum, which is like you have a datum ABC, so it will controls the forms, locations, orientations, depending on how many forms you have. And then if you click this, you will see the result become 0. It's because currently we haven't put in any datum yet. So here the datum reference frame will be activated. So if now you don't have anything, this will be deactivated. So if you activate it, then you need to input your datum at here. Same, you can use your drop down list and to do so. And the next ones, which is the XYZ, this will be the same concept as the datum ABC. It's just that it will straight away use the your current coordinate system here, like that. So you will always see that for a form, the deviations is always lesser than you have a datum. These are always. So that's it. So here you will also see the same things, like same sections like actual value, nominal value, all this. The next one will be surface profile. And you can see it's similar, but here we need to choose surface only because it's surface profile. And then the rest, so far the same. Okay. So this is what we have here. And the next one is all these positions. So this is true positions. So let's say later I want to find the true position of this circle 4. Okay. And then okay, let's say let me share a new screen. So this one, can you guys see another screen? Yep. Okay, so basically this is the side surface of the block, which is the green surface. And then the top surface here, this will be my datum A. And then this is the blue color one is from the top view. So based on same as my alignments, the bottom one will be the datum B, and on the left side one will be my datum C. So I will evaluate the true positions based on this ABC. Then let me switch back. Okay, so if I want to evaluate the true position of this circle based on this A, B, C, very simple. Just go for positions, and then first, this is a feature. So 22, and then my element is circle 4. So this is circle 4, and then this one is the tolerance zone. So it's like in your stated in your drawing 0.1 and then or 0.05, you can change it. So 0.105. Okay. And then the next one is my A. So this is the top surface is my A. It can be XY planes. Yes. But if you want to choose your plane, it also can. And my plane will be plane 2. So plane 2. And then the next one will be my line 3, this one. So choose accordingly. And then the next one will be line 4. Okay. So you can also see a preview here. And you can see this red, green, blue, which is the RGB in the color. So basically the red one will determine the primary datums, which is our plane 2. And then the green one is the second one, RGB, will be representing the secondary datums. And the next one will be the tertiary datum. Okay. And if we have like maximum material conditions, we just turn on. If this is a circle, then we will definitely have a maximum material conditions. And then we just need to put in the circle diameter that we evaluated before. I will make an example later. And then here you can see first is the actual value and theoretical value, which is this is the same as a nominal value. So in your drawing, you will have a value in a box like that. So that one is called TED, theoretical exact dimensions. And then from the secondary datum, which is the line 3 here, the theoretical exact dimensions will be 9.5. So it is shown like this. And next one, the other will be 57.5. So if this is not correct, you can adjust it yourself also. And the last one is you will get your deviations. And apart from this, right now, you can see this small icon below. Means that now this is in Cartesian coordinate system. So you will get X and Y, either ones. And then if you change to this, then this will be like a polar system. And you will get something like a radius, which is the 58.281, as well as the angle, 99 degrees. So depending on which one you are using, and you can see that now the tolerance zone here is in a round zone, means that it's enclosed in a circle. And then this is the positions, and it's in yellow, which is in the warning zones. Okay, and this is in a circular zones is because here we are choosing in a cylindrical now. Tolerance zone is cylindrical. If we change it to parallel planes, you will see that we have two planes now, and we have one more section here, which is the orientations. And you can see right now the orientations is perpendicular to line 3, which means that this tolerance plane, these two, is perpendicular to this line 3. So you can see it's actually 90 degrees to it. So your tolerance zones will concerns on the deviations in this x direction. So that's why here we only have one result. So it also depends on how the drawing and how you interpret it, and then when you will use this. And if you are not going to evaluate the tolerance zone in perpendicular to the line 3, you can also change it to parallel. So your tolerance zones will change also. And then now this will be 9.5, this one. Okay, and you can also not only change line 3, you can also change line 4. It's the same. You want to change this also can. It's the same. So these are the parallel planes tolerance zones. And then usually we use this. And now we still have one more spherical tolerance zone. So this will also include up the deviations in the z directions. So you will see that it is enclosed in a sphere. And we have one more value also, which is 0, which has no effect at all. So here we can also have a spherical coordinate system. Yeah. So this is how we use the true positions. This is a new one. So that's why we can have a preview here. So it will preview that whether your coordinate system, which is your datum reference system, is correct or not. It also shows you a preview. Okay. Okay. Let's say I still want to evaluate the tolerance of this circle 4, but my datum will be at here, center of this circle. So let's say my datum will be at origin will be at here, and then it's pointing towards this circle too. So let's see how we do it. So for positions, circle 4 also. Then what I need is only a cylindrical tolerance zones, and then plane 2, and then here I need my circle 3. And here will be my circle 2. So you can see actually the reference is at here. So meaning to say that this you can interpret as the red one is the primary directions, which is the primary datums, plane 2. And then the second one is a circle 3, which is represented by the green line with a dot on top. If you don't have this, means that it has no if you don't have the circle 2, means that we don't have we don't have a directional constraints. Okay, so means that you only have one value here, which is 25, which is the distance. And then, but if we input the circle 2, we will need to consider for the orientations also, starting from here to here. So you will get a 180 degree. Okay, yeah, and these functions, like a preview like this, is only available after is available, I think, yeah, this version or last version. But yes. Okay, and I think that's all. Yeah, here is you can change the calculations method of your circle 4 at here also. Means that you no need to go to measure again. You can straight away choose here, and you will see that actually there will be a different result. Okay, and we can put the maximum material conditions also. But I'm not sure we have or not. If we need to put the maximum material conditions, we need to evaluate the diameter of this circle 4 first. And then we will put in, then it will work over. Okay. So I think this function is very useful because the customer can see where is the reference, and then it's more easy for them to determine whether they are working correct or not. Okay. And then this effective length is not useful in this case because we are just evaluating the true positions of a circle. So circle is actually a 2D element, so there is no depth or such things. So we don't need an effective length. So you will see that it's also 0. But if we are evaluating the durations, the true positions for a cylinder, then it definitely have an effective length. So there will be some value here. And also we can also set a boundary, like we set a plane on top and plane below, and then we put in the plane to set a boundary for them. It's the same as this value. If there is a 10, it's the same. So you can see the tolerance zone now is greater, because just now if this is 0, there will be only 2D. So if you are using this, it's also the same, it's just that you limit it with the planes. That's it. Okay. Evaluate. So this is about the true positions, which is the new functions. And then is a coaxiality. So this is to find whether the center of the two circles is concentric or not, whether they are at the same center or not. So I need to have a 2 circle. So let me choose this circle and this one, circle 3. So you will see this is what I need to choose, which is the elements, and this will be my datum, which is the circle 3 I choose, and then here is the tolerance zone. Okay, and then that's it. Then you can see the deviation. It's actually quite similar. Features, element, tolerance, deviation. Okay. And then what is the next one? Will be the symmetry. Symmetry actually is the same as coaxiality. It's just that coaxiality is for a round elements, and symmetricity is for a flat element. It will be the same. Means that if you have 2 planes, like one plane here and the other plane at there, but it is still at the middle, then we use this symmetricity to check whether they are in line or not. So basically it's the same as coaxiality. You just need to put in the source elements and then your datum. That's it. And then the next one is the angularity. So for this one is to check the angularity of maybe like 2 planes. Like maybe I want to check the angularity between the top planes and the side planes, which will be my plane 2 and my plane 3. I will use this plane 3, which at the side be my datum. So you can see once I put in, first we will see this purple or pink, something like that. And then this actually will define our tolerance zone. So if I reduce this one to 0. So you can see actually for these planes is actually more near to the more near to out of tolerance zone. Yeah. So you will see that these planes will become yellow. But if I change back to 0.1, so this thing is still in green because 8 microns is still very small for 0.1. Okay, and then you will see these theoretical exact dimensions, which a bit similar as what we have in a true position just now. So in the drawings, if they ask you to evaluate the angularity, you will also have it will give you a value in the box also, and then stated the theoretical exact angle between this top plane and the side plane is 90. So here is will be the one. And then the next one is the effective length, is that you can change the area for the evaluations also. So let's say now it's 30. So this will be smaller, or you can use a limit planes to limit the area of evaluations. Okay, and then now is the 8 microns, so it's just checking the angularity. And if we pick this, means that it will take into account the form durations of the plane too. Because if we deactivate this, then the 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 angularity is just calculated based on the plane 2, but not taking the form durations into account. So you will see that it have a lower value if you take it in, if you have more durations. Okay, depends on manufacturer also whether you want to turn this on. The next one is a parallelism. So if your eye opens, you will see that quite similar as just now what we have. Okay, then let's say I want to have check the parallelisms between this plane 4. I think this is plane 4 and the plane 8. The plane 8 here. So I make use of this plane 8 as my datums. So plane 8 will be at here. Because this is to enter my datum. And plane 4. So it will be have the same things, durations, and if you want to take into account the form durations, you will have this also. And then here we can also limit the area of evaluations. And right now it's in have 2 values because it's a plane, and then they need to use up the area, length time width, and so on. So that's why we have 2. Okay, the rest no more. And perpendicularity. So it's also the same. Is you choose the source elements. Let's say I choose the plane 2 top surface, and then my datum is the plane 3. I want to check for their perpendicularity. So you can see, actually the like angularity, parallelisms, perpendicularity is similar. If you want to take into account the durations, then just take in account and then evaluate. Okay, and then the next one is roundness. So run out is a run out. So usually run out separate into 2 different run out. So one is a circular run out, and the another one is the Asia run out. Okay, so how does this mean is this one? I share a new screen. Let me know if you guys cannot see it. So basically, this is a circular part. This is also a circular part. And then the light blue color things will be the datum A. And then I have a cylinder at here also, the dark blue ones. And then if in this case, I want to check the run out of this cylinder relative to this datum A. So this one is called what we call circular run out. So it's checking its roundness plus its positions and concentricity together. And if we are checking this plane, the top plane, and then compare the run out to the datum A. So this is what we call the run out, ACL run out. So it's actually checking the flatness plus the perpendicularity and so on. And it's only checking in one single in a single line like that. And then so this is called a run out. But if it is checking the whole surface, then that one is a total run out, which we have a double arrow here. So this will be what we have in run out. So actually it's very simple. You can see the datum call out is actually tolerance and datum. That's it. And then you just need to put in your source elements and then the datum. That's it. Okay. And then what we have in total run out will be also have the same things. Just put in the source elements and tolerance and datum, and we will get what we want. Okay. So I think I've taught all of them. Any questions? Any questions for output? No. No question. Okay. So next I will proceed to report. Okay. So let me write report. Okay. So to do a report, do a completely new report, I can go to parties, new, and then report. Here, I can choose how I want to create a report. For example, I can create a brand new report paper, and then I also can create a new report template, or I can straight away create the report by using the report from template, or I want to do a completely blank template, blank reports. It's based on what I want. So let me start from the first one first. So this is the report. So if I click, it's a blank one. So here, you can actually see there are graphics and table. So these two are the most important one, because if you want to put in your features like your elements and then what you have output before, like true positions, your coaxiality and so on, we need to have this. And then the rest, all this is you can put some text, you draw some arrows for your report, and then put some image like the company logo and so on. So let's say I make a rectangle, so you just do it like this if you want to customize it for the customer. And then you can put a image. Okay, then if you put the image, you can go to this object here, and then to choose how you want the image to be being adjusted. there are a lot of options. Okay. Then you can also put some text and then put report. Then got this. Okay. You can also change the font. All this. Oops, what is this? Okay, you can also change the font size. Just drag. And then if you want to put in some variables, like maybe you want to put in the piece number, and then after you key in, you can insert some expressions. And then under here, you can go to look for your workpiece and then the workpiece ID. And then you also can add some words with descriptions. Okay. This can customize all this, and then you can also do measurements, and then go for the same method. Choose for measurements and then ID, and then you can put what is the times that run this that I create these measurements. Okay, and then you press OK. And every time when it increases one measurements, then it will increase automatically in the report. Okay. So if you think that this one no filling, okay. Okay, everything can be customized. And the next ones, if I think the header is good enough, then I can put graphics. This one. And then when I put, you will see this things like this. And then here you can choose either you want to put elements, straight away to put in your elements, or you want to put the features. Depends. So let's say I put some circle first, and then put a OK. And then here you can drag your CAD model. So if you have CAD model, this is the best solutions to demo for your customer. And then if I don't want all this, if I think very messy, don't want. Okay, just drag here and there, and then adopt the view. And then here you can have your all these informations. You can also drag here and there. So you can see it's pointing towards this circle, pointing towards this circle, and this one is pointing towards here. So if you want to change all these format, like their layout, you can go to objects here, and then you can change the element label template, because this is elements, by choosing it. And then if you want to change all of them together, just right click on this graphic and then select data labels. Then it will select all of them, and then you just need to adjust. Oops. Okay, then if you want to adjust all this, if you find that okay, all of them does not suit what you want, you just double click on it and adjust the information. So right now this is element reference. So if you don't want, you just press delete it. And then if you need something like magnifications, then you just put in, double click, and you will put in. Okay. So depending on how you want to adjust it. So if just now I move the width, the width will also increase. Okay. You can also change many things, like you want to change it into a arrow, but I can't find the arrow. Oh, this one. This one, you can also change it on depending on own requirement. And the next one is if I want to view that I don't want already, and then I add a new page, and I can put a table. Just drag. And then these are all the features. In the table, I can only you can only put in the features. Meaning to say that if I don't evaluate any stuff, means that I do not give any output, like diameter, like true positions, all this, then there is nothing in my table. So in order to show it in the table form in the reports, you need to output it. And this is why output is very important. And you need to output correctly. So let's say I want to from 1 to 5 only. So I choose 1 to 5 by using the shift or control, depending on how you want to choose. And then just drag it to the right side by clicking on this button. And then you can also adjust the order. So adjust it like this by using the arrow beside. And at here you can also give some text, and then it will be inside the table also. Okay, so it'll be like this. So my text, and then features number 1, 5, 3, 2, 4. Okay, and then these things you will see that there is some SX, SN. Previously we don't have, and then this is what I mentioned this morning is when you output for the 2-point size, then previously if you simply look at the report, there's nothing. Then you need to consider which one is which one, especially if you're using an envelope requirement, and a bit confusing. So right now we have this. Okay. So now if you need all of them, you can simply tick on these all features, and then okay. So you will input all of them in ascending order, which is starting from 1, 2, 3, 4, 5. Which means you cannot change the order. If you need to change the order, you need to drag in one by one. So if it is too many, it will continue to another page. And here, just now in the graphics, we can change this format ourselves. In the table, we can also change it. Just double click it, and then you can see a layout here. So you can change it if this is not what you want. So let's say like maybe this is the last one, which is this graphics I don't want. Then just because this one is merged, so delete it, and then okay. So we don't have the last sections. Is you need to do it for the first time. If here, if under the object, the layout don't have the layout that you want, you need to customize it for first time. And then after the first time that you customize, you can go to save this layout so that next time you can use it again. So let's say save, and then save as desktop. So this is table layout. Okay. Next time if I if I want to switch back, so let's say I want to switch back, then I just need to double click and then go to layout and then open. Click this open, the international standard, international symbol, and then desktop, and then find this table template, and then just press OK. So everything will be back. So this is how we do a report from the blank one, from a blank paper. Okay, let's say now I complete the report. I want to save it. So go what is save your report. And then you can choose the locations where you want to save the report. So I save in the desktop the training folder, and then you can choose which format you want. If this is in a Quartis report format, means that if you it can only be opened in Quartis, and it's the same as what we have right now. And then you can also save as a PDF form and text file, as well as the CSV file, which is the Excel format. Okay, so let me save as the PDF format, and then here, this is the file name. If you put a file name like 123, then every time it run the programs, then it will replace the existing folder. So we need to give some variables, like maybe how do you key in all these variables? You just click this expressions editor, and then this will prompt out the window status system as what we have just now. And then we can edit all this, like maybe we only need the workpiece ID. And then if you need to add some text like this underscore, or maybe you need to key in something, we need to put open and close I think it's bracket, the symbol here. So open and close, and then type anything you want inside. And then you can also put in the time, which is the time now, 1 p.m. Yeah, and this one. And you can press OK. There are a lot also. You can put in what you want. It's under here. And then save. So after you save, there will be 2 commands. You can see here. So first is the create report, and then the second one is the save report. So if let's say you have done this program, you have done your report also, but the other day you want to edit your report, but you don't want these things to be shown in the report, then you need to double click here. Double click at the create report to go in to edit your report. And then after you edit, you need to press this add. If not, your report will still same as previous. Okay, so this is create a report from the blank one. Right now, if we want to create a template, we can make use of the template from the factory. Comes along with the software. You can choose and then opens, and then we have all this. So you can see it's a bit similar as what I've done just now. So logo, all this is pre-done for you. And then we have all these also. Okay, this thing we can change also. I will show you later. And then here is the graphics and the table. So graphics and the table is done for you. You just need to double click. and then put in what you want. Okay, like let's say I want to put in the curve. Okay, and then take this minimum and maximum point, and then it will show me. Then I can turn on this element graphics. Oops, before that, here I need to put curve one. So I can have open up these options to colorize the elements in the left element window. So I can see the blue points, green points, and some blue points also. Blue point means that is a points that is in negative side. Green points means it's okay, and so on. After that, okay, dot view. Then I have this my curve ones with the minimum and maximum value. I have no idea why this have no value. Okay. And then with the value also, this one, as what I mentioned just now, this can be changed. All this. Okay. You can have a lot of graphics, not only one. You can add in more and more. As well as the same as the table, you can have more table, more graphics. Depends on how you want to do your template. So this thing, table, just double click and it will comes out what we have just now. So if we are using to create a report from the report template, it is very fast. You just need to double click on the graphics and the table, and then all this is done for us. Okay, the next one. So let's say if you want to create a report template. So next time we can straight away to use this report from template. So let's see how to do a report template. So first, we go to the object, and then here have a report paper. We have the options to put in the report paper. You don't want to put it also can. But if there is an existing report paper, you will just use it like this. Comes along with the software. And then here, you can see right now it's still blank, but you can choose which report paper you want. This, or maybe this, like whether which one you want. Okay. Then you can simply put in, maybe here first you want to have a graphics on it. Then how your graphics all this to be. And then you can also add in a new page. All this. You can also choose to put in a table. Okay. All this. So after you have done, which you can also choose here your margin, like your paper margin, like which format you need to use, either portrait or landscape. How you want to make it. It's just something like a drag and put in and then drag like this. Okay. Then you just need to save report. And then now you are saved your report as a as the format Quartis report templates. It's different from previously. So now you are saving the report template, and then let me use 1, 2, 3. Save. So next time if I want to create a new report template I created just now, so I just simply open this, and then this will give what I have done just now. So if you need to create a new report template, just create it and save it. Then the next is create a report paper. So basically, right now here, everything, this thing we cannot put. We just can put some text, some line, which is the drawing objects, some image, all this. So we can create the header and the footer. So the purpose of the report is for us to create the header and footer and so on. Okay, so it's the same like what I did just now. You can put some photos. Okay, so it's just put some photo and then put some text that you want, like measurements, which workpiece and so on. Then what you need to do is just go to save your report. Yes, in a Quartis paper. Then after that we can use for the template again. But right now I think I will show you how do we edit the Quartis paper. So open report. Where's my report? Report paper. So now I have opened the report paper. Then just now you can see that actually I cannot click on all these things because it's a fix. But right now I can click on it. So basically I can double click and then I can change the stuff I want. So I think by changing all this, if you really need it, is more easier than you create a new report paper yourself. Okay, so just double click to edit it. And then, okay, same for the rest of this, the same. Definitely after you edit, then you need to save it. Save your got this report paper. Okay, any questions for the report? No. Okay, then I continue. So after all this report, after this report, I think I will talk more about these programs, which consists of like you can put in some media like jump, branch, and so on. Okay. So let me show you some function first. So I have this part, and then I have a trough circle. So I want to measure all of them, and then if I think I want to click one by one, I think very troublesome. Then I will I will use the loop functions. As what you can see, I have here. This is a loop and then loop. I have another loop also. Okay, so assume that I have already done the alignment, and then what I actually did is I make use of the loop functions insert a loop, And you can see here is a start value. So means that this loop is starting from which value? From 1 or 2 or 3 or 4 and so on. So let's say I want to start from 1. Very normal. And then I have 12 circles, so end at 12. And then step width means that 1 plus the step width become the next value, 2. So if my step width now is 2, so the next value after 1, which is the start value, will be 3 and so on. So it will be 1, 3, 5, 7, 9, 11, 13 and so on. No 13, so it will stop at 11 rather than 12. So if this is 1, then it means that it will run 1 by 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the loop index, this I is by default, but you can put something like A or ABC. You can put anything. Then okay. So right now you can see we have a loop A, and then from 1 to 12. In the previous version, you will not see this 1 to 12 here. It's the latest functions, and right now I want to measure a circle. So, and then reference, I will simply choose the nominal value. And then let's say I want this, the green color one. No, the one in front of the green color to be my first circle. So left click, right click as per normal, and then check out all the distributions parameter as well as the safety plane. And then here for the name, if I simply just put the circle underscore 1, then that means that if the loop is running on, then it will always be circle 1, circle 1, circle 1, circle 1, and then it will replace the previous measured result and then replace it with the new result. So I need to do something on it. So double click on it. You will come back to this expression editor. So what I want it to be fixed is just actually the front part, which is this part. So I want them to be a text so that it will fix all time. I'll put this open and close comma, I think. I don't know. Okay. So right now you can see below the result is a circle, which is CIL underscore. And then I need to plus some variable. So put on the plus. And then we can have something like yes, I know, but I need to find out. Yes, SDR. But if you know, you don't need to go to functions and then conversions to find. You can simply key in if you know. Once you do for a long time, then you will know. Then right now this is A. It's because here I put A. As you can see, what I did before is I, because here is I. So it's based on what you have give just now. So here you can see circle 1. Then when you run the loop and the loop goes to the loop number 2, then you will have a circle 2, circle 3, circle 4, circle 5, and so on. Okay. So after you adjust, this will be in yellow. This will be in blue, light blue. Light blue color means that you have some expression editor, which means that you have some variable inside. If this is a fixed value, then it will be like all these things in a black color. Okay, so right now actually I'm running the circle alone only. So you will see I have this circle, And then after I have this, the next step definitely is to adjust which is to rotate the coordinate system. This my coordinate system. I need to rotate along the z-axis. Okay, this one. I need to rotate along the z-axis. So what I need to do is go to here, align, and then rotate. So I have 12 circles. You can count 360 degree divided by 12 is equals to 30 degree. You can count, or you know the number, then you simply put at the divisions here. It will calculate for you. Then it's either you want it to be positive or negative. It's just you measure it counterclockwise or clockwise. That's it. And then okay. So you can see this coordinate system is going to rotate, and then the x is pointing towards the circle. So if I rerun this part, it will measure one circle and then rotate, and then go to the next loop, and then measure the circle again, and then rotate again, and so on until it complete the 12 loops. Okay, so if I run, like maybe just now I have maybe just now I've rotated the coordinate systems, and to measure this first circle, actually I need to rotate this back manually. But if I forget to rotate and then I start to run from this line number 2, in these new functions, in these new versions, then it will prompts you whether your coordinate system is correct or not. So let me show you. So first, how do I run the program, right? It's just right click, and then I want to run starting from the line 2 instead of the line 1. And then I can click on execute from cursor. But if you want to run from top, you simply just press this execute button. Okay, but right now I want to run from the line 2, so execute from cursor. Okay. Okay, let me run again with the proper setup first. So after it runs the first circle, you will go to run the second circle, and you will see that it's named as circle 2, which due to this circle and then plus the str, which stands for the string, and then a, and then now this is the third loop, and now this is the fourth loop. So if you have a lot of identical holes which they have a equal distance with each other, then you just simply use these loop functions. It doesn't need to be a rotations. You can also be in translations, like maybe translations in the x-axis as well as the y-axis. You can have a loop within a loop. Is fine. Okay, so this will be the last circle, and then you can see, yeah, it stopped here because it has completed the curve measurement. Okay, so I switch back to part coordinate system 1. And the next step is if I want to find the if I want to find the true positions for each hole in the previous versions, we also need to output the true position one by one. Okay. But now, because we have these new positions, we don't need to click one by one. Basically, just do another loop and then go for position. And then here, be a string A also. So my features will start from 1. And then here, just get the expression same as just now, what I have. Same as the measurement here. Then here I can simply choose my datum first. Okay. And then here, right now I'm in I can use a cylindrical Cartesians. Let me see, am I doing the correct things? I think so. Yeah. Oh. Okay, so right now this is my circle 1. So for the theoretical values in the previous versions, this is a fixed. Means that if the circle is at another locations, we need to output again, choose here circle 2, and then here can update. But right now we don't need. Okay, because in this I am in a cylindrical coordinate system, which means I'm checking the true positions based on the polar and the based on the radius and the angle. So what actually is rotating is the angle. So it will always be like 75 radius and then 0, 30 degree, and then 60 degree, 90 degree, and so on. So this is the latest functions, and then we can make use of this. So just double click on it, and then it will comes out for the expressions editor also. So basically what you need to do is just you need to put in some variables, put in some functions, depending how you want to make use of this. And why is this functions is because when the a is equals to 1, which is at here, then 1 minus 1 is 0, so the degree is always 0. So when it becomes 2, so 2 minus 1, 1 times 30 will become 30, and then 60, 90, and so on. Okay, so you can have a lot of functions. Okay, then the next ones just need to evaluate, and then that's all for my these positions output. So you can see I just need to put one time, and then it will output the true positions for most of the for all of the circle. So let me run. So you can see this is the benefits of having the latest true positions, and with the use of loop. So we will have all these 30, 60, 90. In the previous function we cannot do this. I think this is very nice because okay, so this is how we do it. You not only for true positions, you can also use it for maybe like positions, distance, or this. You can see if you go in, for what version got these functions? You mean for true positions or what? Shinho, you mean the look for true positions? I think it's last versions 2019-2. Let me check. I think so, but it's just a 1 or 2 release ago. Okay. Oh yeah. Starting from 2 for other result. Yes. For other results, it is also the same way. It's starting from 2019-2. Okay, and then for the other result, I think I'm not sure it's which one are either positions or distance. Is either one. Now we can also double click on here and then put in the expression editor in a loop. Then you can enter your function yourself also. Yes. Okay. So and then just now I want to show one more function. Let me try. This one. Okay. So now if I run the program starting from top, which means I use this execute button, and then this program, this system will load the coordinate system PCS1 first. Okay. But if I run from the line 2, which means as I right click and then click this execute from cursor, and then click, you can see actually there is something new here. Status deviations from the program context, workpiece coordinate system 1. Okay, what this means is that the system detect that your programs should have a PCS1 before running the line 2. But right now here, what we have is we have no PCS. Okay, but if then it will prompt you whether you want to change the parameters, which is the system will help you to load the it is also a new function, yes, load the coordinate system, and then if you want, then you just press this change parameter and execute programs. Then you can see it's actually load the PCS once and then run it at the correct way. This is can avoid collisions, because sometimes we might have use a different prop or what, or different different coordinate system. Yeah, and then this will check for us. Yes. Okay. So basically, I think this is good. Yes, this is a new function. Upgrade. Okay, let me finish it. And one more functions is that I think is very nice in this version 20201 is that if now I want to run this loop, maybe like run first. Okay, let's say it runs circle 2, circle 1 and circle 2, and then I stop it at circle 3. Maybe in the real life due to some collisions, something like that. And then I want to run this loop again. But right now, if I press execute selections, and we have one more function is that we can choose to start the value at which value, which means that we can start the loop at which loop. In the previously we can only start from beginnings, and then previously I do a program I need to execute always from the beginnings, and then now these functions I can simply key in what value I need to start from. So let's say just now I start at stop at 2, and then now I want to start at 3, so just press 3, and then you will run here. and then it will continue the programs until 12 like this. Eh? Okay, I think it's because just now I'm just pressing this execute selections. Yes, good. No need to start from first. Yes, I think very good. Yeah, right now it will continue. Because just now I click the click the execute selection on me. Okay. Maybe if you guys got any like any idea or any things that need for these two upgrades, you can let me know. Then I will feedback to the developer. So did have any shortcut key? Shortcut key for which one? Example to take element. Oh, example to take element like maybe at this circle 11 is it? Am I right? Tak ada. Oh, tak ada, yes. Okay. And okay, let's say I have a lot of program now. I have let's say I have okay, let's say now I have a lot of programs. Let's see for my programs, I have all these programs. And I want to close one by one. So click one by one. So the new function is also this one. And then click close all program. So it will close everything. Okay. And then same for the program is like I have a lot of program opening. I want to choose right. Maybe I want okay, this 011. I need to scroll this button here and there. Very troublesome. So what I can do is that if I am this Premier, unmute. Okay. Okay. So just now I said that if now I'm at number 3, and then I want to open this 011, find this. You need to scroll here and there. So I can also click this. So it shows you a list of all open programs. So you just choose 011. That's it. Close everything, so just close. Okay. Any things or anything need to know? Hello.
Okay. Any questions?
Okay. If I have questions, then we can then I can raise one more questions again. Um. Okay. So I think this function is also good enough. I also don't know what is this, which version have this. So basically, if you this, and then you can choose which measurement you want to add. Definitely not negative one. Okay. So if I put 1 and then I put okay, so means that if I run these programs, then the system will automatically add one measurement for me. So the next time I run this program, then it will become measurement 2. Yes. And then it will not override the result in the current measurement. So it's useful if you want to compare some. Yes. You just need to record and then add this in. You can add before you start to program everything. Because if you add this after you load the PCS, then this will be clear. Any questions? And one more important thing is for customer is that right now the database we can save up to 99 copies. It's very safe. If if the customer need it right now, we have this function. Then you can change it under the this quantities options and then database just yes, previous is up to 5 or 6 only. Yeah, I think it's 5. But right now all the default one will comes with 5. You can have lesser also definitely, but the maximum up to 99 is very safe, super safe for customer. Okay. Okay. Any more stuff that that you guys want to know? Oh. Oh.
Okay.
Yes.
That's it, right, Ching?
Yes.
Okay, guys. Any questions?
Understand. Okay. Y and Marcus come. What email and you says to
Okay, so I open my webcam first. So this today is the basic training. So we have also the advanced training. If anyone interested to have this advanced training, please write me an email. Okay.